Welcome back, ladies and gentlemen. Continuing our discussion of optical activity. And keeping in mind that yesterday we had a problem that was definitely not that well thought out by me, and it was a disaster. So we're doing a new one, and hopefully I grabbed it from an old semester. I hope this one's a little smoother. I did redo our activity yesterday in the evening, and I used the same one, but I changed a couple of the numbers to make it work better. So definitely watch that video. And hopefully after that one and this one, you won't be like Miss Nasser yesterday and say, I'm just going to skip the question. And I also have some tips on that video about not giving up on this question. If you get a wrong answer here, and you know it's wrong, don't stop. Invent an answer less than this number. That's the maximum rotation you can have for a pure molecule in this question. So just invent an answer with the same sign as in the question. So say you know you screwed up. So invent like plus 13 would be a nice number. Trust me. If you put plus 13 here, it makes the next calculation real easy because you're going to divide 13 by 130 times 100. You're going to get full credit down here for your 2 points. So pick a nice number that, since you screwed up, try to make your life easier. Okay? And you can get those two and then these 3.5. Okay? So let's deal with this question. I confess to liking quarters and thirds the other day. I think I have another one where this is best expressed in quarters, right? That's a quarter of a gram. So make it so. That's a G there. And centimeters needs to be what unit? You can't use centimeters. Decimeters. How many decimeters in 20 centimeters? Remember, there's 10 centimeters in a decimeter. There are, because there's 10 tenths and 10 hundredths and a tenth. Well, okay, that's hard to say. Did you say 200? Oh. No. 10 centimeters is 1 decimeter. 10 centimeters. That's double 1 decimeter, right? So it's 2. And that's all the changes you need to do. And then the equation you need, and you got to learn it. If you want to standardize your observed rotation, you take your actual observed rotation, 2.60, and divide it by concentration, which is grams, 1/4 gram, over milliliters, 10 milliliters, times the path length, 2. Now, some students prefer, because they have trouble with the numerators and denominators, some students prefer doing it like that. 2/1 is the same as saying 2, right? And the 2 and the 4 definitely simplify, don't they? Just look at the denominator, and I'm talking about only the denominator. So in the numerator of the denominator, you got a 2 times 1/4, which is the same as 1 times 1/2, right? So let's do that. That became a 1, and that became a 2. And I think that's as simplified as we're going to get. No worries. Write down what you get. I'm going to go slow. Most of you could probably skip a few steps right now. I'm just writing down what's left over, just so it's very clear. Okay. And step by step. 1/20. 20 times plus 2.6. Is that right? Yeah, how do you do that? There's some long math here, but it's not terrible, is it? It's basically 2 times 2.6 and then put a 0 at the end, right? So 5.2 with a 0 at the end. 52. Not the nicest number, is it? Wonder why I picked that. Sorry? There's simplification that's gonna, I don't know if 52 is a great number. I don't think I picked the best numbers here either, but at least they're not incredibly impossible. Okay? So did I make any mistakes? Maybe that's the thing. I got the quarter, I got the 10. Grams over milliliters. I got the decimeters is 2. I got the plus 2.6. 2 times a quarter is the same as 1.5. I got the 10 still. Everything worked out. It is what it is. Percent EE. So you got to compare this new standard value for your lab, which is observed. Observed means lab, to the standard value in the literature for the molecule, which I have to give you. It's right here. On the test, it was straight across the screen at the top, but it didn't fit. So what do we got? 52. We didn't get this far yesterday. We threw in the towel, remember? 52 over the reference value. And what do those straight lines on the outside mean? Absolute value times 100. Maybe this thing does simplify. I don't even know. Divide by 2 at least, right? Maybe 4. I don't know. 26 over 65. Is that right? And you know, if the numbers aren't perfect, I'm going to accept this. Isn't that just a hair over 50%? What's half of 65?
32.5.
32. So we're less than half, right? Can I simplify this anymore? I don't think so. And I don't want to do long math. So if the numbers don't work out nice, I'm going to accept approximation. So, you know, half would be 32. 65 is not that far from 50, right? So every 2 is 1%, right? 65 is not far from 50. We're ballparking here. So 32 would be half, and I am 6 below that. And each one is roughly 2, because 65 is like 50. I don't know if I'm explaining worth anything here. Give me I want your estimate, and then we'll break it down. It's not, please don't give me more than 50%. That's just a bad estimate. 40%? Sound good?
Yeah.
Ballpark? I mean, if you have the time, which nobody does, as you figured out last test. 65, that's 3, 4. 4 is too much. 4 is right on. It is right on. And it's 44%. Yeah, 24.6. It is 40%. Yeah, not roughly. There had to be a way to break it down then. We did have, I can't get it to 10. Okay. Give me a reasonable estimate there. If your estimate's not reasonable, the most I'm going to take off is 1 point. Okay, and then you can still get like 90% on this question. What percentage of the sample was molecule X? Okay, here's the deal, everybody. It's got 40% more of one isomer than the other. That's what 40% EE means. Don't invent your own. It means 40% more of the major isomer than the minor. That is the only interpretation of that. Question 1, I could have answered before I did anything. Which one is the major isomer? You don't need to do math. You go back to the question and look at these 2 things. That thing and this thing. They're highlighted. You see them? They match. Signs match. Therefore, there's the symbol for therefore. X is major, enantiomer is minor. You don't have to write this on your test. This is just for your learning experience here. If the signs did not match, then X is minor. The enantiomer is major. There's the two scenarios. Don't invent your own. Every semester I have students invent their own, saying, oh, this one's plus, the other one's plus, this one's minus, the other one's minus. They think that's two scenarios. They both meet the matching, right? If one's plus and one's minus, they don't match. Then enantiomer is major. If both are plus or both are minus. It's not three scenarios, people, it's two. Okay? So I know that I have 40% more X than the enantiomer. We did that work. So I'm going to word it like this. 40% X plus 60%. This is the part of the solution that doesn't rotate light. We had a name for that. I don't know if we got to it. We did get to that name, didn't we? 50-50 mix of two enantiomers? Yes. 60% of the solution is racemic. What's racemic again? 50-50? Well, that means you have 30% more X from the racemic portion and 30% enantiomer. Here's your two numbers. 70% X, 30% enantiomer. What do they add up to? They better add up to 100. Okay. 70% X. And students, when they're studying, they don't remember where that 60 came from. Can you remind them now? And I'll put it on the screen. Because I have every semester students say, where the heck did that 60 come from? That's not on this page. 100 minus 40. The rest, whatever it wasn't, is the racemic portion. It's the part that doesn't rotate light. We're only seeing the part that did rotate light. The excess. The excess chemical is the only one going to cause rotation, right? Racemic mixtures, they cancel. The two separate molecules cancel. There's a zero rotation in that portion of the solution. And now, ladies and gentlemen, 70% is not a hard math. You go to your total, 250 milligrams. Total, 250 milligrams. Please tell me what 50% of that is, and then what 10% and 10% is, because the total is 70%. What's 50% of 250? 125. What's 10% of 250? That's why I like these numbers. Add them up, you get 200. Final answers, 200 milligrams, 70% X. 70%, 200 milligrams. And let's see everything here. There's the whole activity right there. Okay. So definitely doable. And don't give up. I'll stop the video now.